Hey, folks, I want to talk about how I contacted the past. Is how I have to put that there for most people. I don't know. It might have been a thing. I don't know. But I wanted to talk about it because it's like, actually, I wanted to basically talk about how they got very far with imagination. Okay, they didn't have computers. They had calculations at best and some experiments they might have been able to run. That's about it. So it's like, I'm going to talk to them about how to, because renewable resources were already starting to become a thing in the 1800s because the Industrial Revolution was starting to cause microclimate shifts. And people had started to theorize because they had already known the world was not flat. Okay? Like, it's all in a box, and you got trees over here that seem to suck up the carbon and dump it in, and you got some algae maybe or something. But like, it's all gonna come back and it spreads out, whatever. But eventually the processes that are our natural environment do eventually take care of things. But you know what? Back then it was happening so quickly that they had started to theorize some of that stuff was going on. Now, it's not perfect, but it was like, okay, so to some of you, it'll be he was trying to imagine how it is they must have thought and think or not thought and think, thought and feel and went about their processes, as that's what it's going to be. And meanwhile, me, I'm like, well, I kind of sure, why not? Let's just go with that for now. Personally, I feel like I had actual conversations with the people, but that's me. There's no way to travel backwards. I believe you're this, that, whatever. Okay, whatever. Moving on. For those that want to believe, my type of thing, and those that want to only believe that type of thing, you're both welcome to be included here. Now, we're going to go into like how it is that I came up with a a vacuum design that actually helps increase the efficiency, but also output of power and straight up wind speed, wind velocity at the end of our blade design that I came up with a while back. Headphone users, watch, I have to watch out, I'm going to make a loud sound just to knock the remainder of the grounds from here. I did a wonderful modification to my Timor Chestnut C2 grinder here, where there are some washers. There's a bit of tape, so there's washers in between on the shaft here. So the little shaft there on the inside. Okay, there's 3 washers instead of the standard one, and then there's tape right there. I don't know if you can see it. It's not focusing. Point is, it's at the top up here. That makes it so it doesn't wiggle back and forth as much up and down. And the 3 washers put a large amount of spring pressure onto the spring that holds it down. And then I did as you can see, a half-step drilling operation on the plate that's underneath that is the screw-in washer. Which means I can effectively get a greater degree of control on my grounds, my hand grinding for my coffee. As you can clearly tell, I have the flare, good old flare. This is the classic, Flare Classic. All right. Anyways, back to the and this is the controversial, still around. It's changed. I took their criticisms. It needs to be straight, and less prongs will be better. So I took that, but it still works. Took that criticism, despite the massive debacle that was. I've been running it that way for a long time, actually. But moving on. Let's see here. So we take a basic fan shroud blade, sort of like our fan shroud wind turbine, turboprop, whatever you want to call it. Take it like that, pretend that this is a tube, because they're all just tubes. We're going to take a tube, All right. Now, that is a wonderful, cool idea, but I couldn't make it work with a tube until I could make it work without a tube. So, throw it out. That's what I wanted to tell you. Got to throw it out. We're not doing tubes here, everyone. We need to do another thing. Which I need to pause this. I'm going to get some water. Give me 1 second. Alright, got water. Let's see here. Right, so we're going to take two counter-rotating props. But they're not really the same, let's put it this way. The middle part is almost effectively nixed, gone. And this vacuum idea has been done, actually, kind of in a way. Like, it's almost gone. Alright. Now, we have to situate the front blades in such a way that the curve angle creates a rolling vortex along one side that creates a massive vacuum in the center. And as it goes through, because they have to be highly angled and curved and corkscrewed around, it creates and the next one, a way for that to effectively grab a hold. But these are much more vertical in terms of their blade angle design, but they're far elongated. The blade. Instead of this one is a, thin, twisty one, this is a fat, big behemoth boy that's spreading off into the distance. Alright? Now, give me 1 second. I'm going to do the whole coffee real quick. I'll let that steam up, actually. I use the steam because I only get to 93°C when it boils, and it's not hot enough to preheat my stuff. Anyways, in the center, because it's effectively non-existent, close, not quite. What it means is that rotating with the blade's log-style vortex, okay, that is induced along one side of the blades, tends to collapse right where that other counter-rotating part of the blade happens to connect. And so as it collapses and then trails off with the other one, it produces a greater and greater degree of force that lifts in Bernoulli, I forget which one it is. I'm pretty sure it's Bernoulli's, but it takes that air out of the sectional area that's in in between of these two fan blades and creates a vacuum. It sucks it up. Alright? Now, the reason why I came up with this is because I was in a race against Darwin and a few other people creating different fan blade and renewable resource energies as a new beginning technique. That's kind of what I was in. Now, granted, I didn't know in any way any of these funnel things that they came up with. Dang it, where did that fall down to? I'm wasting precious time and heat. Alright, so I didn't know about any of them until later. In fact, I just saw a design on Robert Murray Smith's video that he just came out with today about a stacked series of cones that are interspaced to collect wind and direct it. That is a design I actually came up with myself while doing this, and while talking to Darwin while I was doing my whole business with him. He, took it. So, imagine my surprise today going, oh, that is an actual thing. It looks literally exactly the same as the one in my imagination. So, there's that. That's kind of why I decided to do this whole video to a point. But it was also like, hey, you know what? Throw my hat in the ring here. Because there's other ones, but the point is like, look, this is a way to basically collect wind, and this could be incredibly useful for increasing the efficiencies of some of their steam and other engines at the time that were using massive amounts of coal, and were not exactly efficient, especially by today's standards. Wow, you know what I mean? Like, they would have killed for freaking 35%. You know what I mean? But, point is, it's like, oh, that's a neat design. I like that, you know, that I came up with. And then it's like, right, well, here's the best way to make it, if you don't know. There's these little triangles, you know, like little triangles, and they kind of look like your hand, alright? And if you have them pointed like so on the insides, and you take the cross-sectional area of each one of those tube funnels, and because that's a donut-sized nozzle that goes into this area, and you make a lowered resistance by having it larger there, smaller in the inside, and have those little flanges, kind of like bird feathers. They create a lifting up effect that tends to curve on the inside, but then dissipate pretty much immediately, creating a little bit of a vacuum, but also skips up in towards the inside, while the outside will still try and draw air to mix with it. Okay, and that, along with these nice little channel grooves that are on the other side, so you take the one funnel and you have the one above. The one that's above, you have these little grooves to help facilitate a drop down, you know, or push up or whatever, depending on the angle of the direction that you want the wind to travel. It creates a lower pressure, but it's not really a lower pressure, it's just an area of earlier escape. But it means it flows the given. Gotta have my two cut by myself pieces of, gosh darn it, screwed up the, give me a second, the espresso grind. You will go back in and be pressed in and not screw up anything. Okay, you know what, I'm just gonna have to deal with that. Let's see if this works today. Anyways, point is, it creates a area of less resistance of travel, but also means that it, with the, because you can put bumps, dimples, so on there, it creates a greater increase of drag, which tends to create this lower pressure zone that is, of course, now actually creating those little areas of greater lower pressure, which is a vacuum force, which increases the speed, the velocity of the given air coming through. For resistance, but it's okay. You know, resistance doesn't really mean anything. You're not trying to make it travel faster. You're trying to get the wind to improve its efficiency going through, because you want air mass volume, which is what really gives you your increased degree of power from turbines. The greater the density, it's just not exactly stupidly easy to make occur. So instead you can go for air velocity, which is like a version of pressure, which means is a version of density. Even though they're reportedly, some stupid reason or another, said to be different, when in reality it's like, well, there's an obvious correlation slash straight up like mathematical principle of a certain degree of velocity, I'm sure, that ultimately equates to being like this degree of velocity increase means this degree of simulated increase of pressure, and this degree of velocity means a simulated increase of density once stopped because of the mass inertia flow of the other air that's going to come and show up. So there's that whole part. But then I was like, all right, right. Back to the vacuum in, you know, blade design, or not blade, vacuum design that I wanted to talk about. It's a wonderful little design here. Okay. Now, because you produce a vacuum on the inside, of course, because there's resistance to the fan blade hubs, the place where both those axles are trying to come into, it creates a continuous vacuum that doesn't have the ability to squish, and so it's trying to draw air from all places, but air has already been flowing one direction. And so it creates a greater degree of resistance on one side in other places and much less resistance in one other area. The direction of travel for the wind. Now, it produces an interesting effect once you set it up correctly, or should, where in the blade or wind speed velocity around it will increase, but more specifically the wind speed around the fan blades will also increase, and the given torque that increases as well. And so, as you can see, or my last thing I was talking about was like, oh yeah, no, so it produces this increased torque and all that leads you to, oh hey, yeah, right, that's going to increase the given torque and speed and wind velocity of this windmill. At a cost of course, creating a vacuum. You don't get something from nothing. You have to create the vacuum. Now, it's fairly cheap, actually, to create the vacuum. For a given blade and fan size, and like talking about the right parameters, you have to get it all technical and pedantic and super accurate and precise. On the smaller scales, the bigger scales makes it a lot easier, because apparently the effect is more pronounced, much more easily, with a lot less finite degrees of angle and all the rest of it, and therefore material design isn't quite as costly to make it ultimately work out, which is good. But what it means is that because of the way it interactively skips once the amount of air velocity is achieved, it skips off and it no longer can really suck anything on the inside. The log vortex, as I like to call it, because it's a spiraling vortex that travels along the spiraling fan blade that is traveling along the length of the fan blade hub and to the point, and it actually goes into slightly the other fan blade, kind of like that. So it's a very, kind of, anyways, point is, manages to create this very, very specific effect. Now, that very, very specific effect is wonderful. It's also very, very powerful. It does this unfortunate reaction of creating extremely fast wind speeds, which can be dangerous. In fact, the reason why I designed it was specifically to make prop blade designs work more efficiently, especially since that vacuum area now is more of a, I can take out this cone and turn it into another, or like cone to divert air around into the blades. That is now going to become my air intake for a basic counter-rotating style kind of piston-y engine. It's a turbine, but not really a turbine. You see, the turbine, I don't want it to be. As it counter-rotates, I can use that counter-rotational initial inertia to effectively create the degree of thrust, and as the exhaust is coming in, it's already been compressed through this center and then out approach that can then be fed into a other area, which now, because this is very high velocity and now it has higher heat, then I can put it into a smaller degree in area and then effectively get my thrust for a far greater decrease in size and energy input, because it makes it more efficient. But the reason why I was talking about it was for windmills. So windmills, the reason why I wouldn't ever use it for a windmill is because it's kind of dangerous. We can, it's an overrun effect. If you don't know, like that vacuum, the larger the vacuum, the greater the degree of energy efficiency, and actually input of energy you continuously gain up to a point. There is a degree in terms of the height of altitude, the degree of pressure that you get, that is there to input and impart into the design. It's just like a Stirling fan blade design, so as a result that vacuum will go wonderfully the lower altitude you are, and it can go very, very fast in terms of the wind speed. But the higher altitude, it can still go pretty fast. It's just dangerous because you don't usually want, like, almost, it's not almost, my design, if done properly, from what I can see and perceive, should go well past thrust. It should definitely be a dangerous thing where, like, I'm not saying that you'll be able to run extremely fast, but the faster you go, the faster and more efficient that effect continuously becomes. And so it's a runaway effect, which should, up to the point of where friction and everything balances out, produce you a decent amount of actual, it's not free, you're not getting it for free, but energy that could propel you in an aircraft, which is dangerous. Usually you don't want an aircraft engine just running amok on someone's wind farm or something. Typically, as far as I'm aware, nobody usually wants that. So, and it's not terribly loud. I'll give them that. And it's fairly small and compact for what it is. And the greater degree of vacuum, and because of the way that spiral front part of these fan blades, it essentially draws out a greater and greater degree of vacuum that also goes into this initial inside that pulls the air faster from the front towards this middle area, and then this is going to connect, and then that wants it to go down, and so it does this spin, pull, compress, speed up kind of design. Like how you change the blade angle. Let's say the blade angle is going like that, and then like over here there's wind, and it comes over to a blade angle that's like this, and so then it rockets it up. And that's the same thing indoor skydiving. Blade angle changes help with creating increased flow, but of course there has to be thrust, and so the vacuum is actually thrust. It just produces a greater and greater degree of that thrust for a given amount of energy in the area, meaning our atmosphere, that happens to be our given amount of energy. And the faster it flows, the more energy you gain from that continuation of effect up to a point, and then you don't anymore. Which is why it's like wonderful as a windmill, and then like, I add my engine, and then I end up getting actual real thrust, which it's still thrust that you could probably get yourself with the right aircraft aloft into the air. But usually you don't want to like play around with that. But then I was like, all right, so I'm gonna add because like it's very turbulent-y, it doesn't have a contained area, blah blah blah. Tubes are easy. Tubes are simple. Shrouds make sense, and I can dig a groove onto the right areas on that shroud for the serpentining of this fan blade. And then the other one that is, of course, more flat and then elongated, like a big old wing, that ultimately produces the effect that we're looking for and reduces the air velocity. Kind of. It's all about boundary layer, because it's like boundary layer in that vortex is pronounced only on one side, which is what you're looking for. You're looking for that. On the other one, it's like, oh, right, I'm just trying to produce this increased degree of flow across and then spread out that, as it goes faster and faster, shock wave that's likely to occur. But if I'm able to put a fan shroud, I can then actually just, again, re-angle it and then have it go up slightly and then delay its effect, have that angled shock wave at the tips of these fan blades / knife edge of the fan blade. That ultimately means that produces its own version of a counter vortex to reduce the loss of efficiency and increase the degree of this effect, but also give me greater degrees of velocity for this airflow, which gives me another increased efficiency profile for my windmill / turboprop design. But then I was also like, okay, so then if I do it on this rear then, and I do it on this, instead of having it go into the fan blade, I can have it continue to stick out. I can increase the degree of vacuum produced, but also make a counter rotation that speeds up the flow even greater degrees with the correct stator, meaning little fan blade that stick in that are properly placed to effectively create that double counter rotation that gets rid of this shock wave by making it denser and faster flow, traveling along for the next vortex and so on to the final part of the end in the fan shroud where these blades are. But then they collapse, and so they have to collapse, and so like I have to put it on this very specific, instead of an expansional part of the tube, we're collapsing. So it's the Bernoulli's, the triangle pyramid tube thing. I don't really give a fuck. Truthfully, it never really mattered to me. Point is, it's just a tube that's smaller diameter, that's the proper given slope angles and grooves, that effectively means that it then collapses these very fast flowing rates of air that are much denser, quotation marks, denser, than, something else. But point is they collapse, and they kind of balance each other out by, instead of continuing a rotation, it's going to bounce into each other and then produce, instead of a continuation of that spin, a thrust, a direction of travel that is opposite. So as a result, you get greater degrees of velocity achieved, and then you also are able to be more efficient with the design, because that produces its own version of a vacuum where they're not collapsed, which again helps increase flow. And so as a result, it continuously creates a very, very, very strong flow rate for very, very, in fact, almost no energy. I mean, you have to have energy input. There's no way to get around that. No perpetuals here. You have to put energy in. You also need an atmosphere. You can't do it in a vacuum. The vacuum's the vacuum thing that's providing the effect that this is producing, which is the same equivalent of any lift or downforce effect, just being utilized to increase flow rate velocity for the given design, and as a result, correct torque values of the counter rotation, and a proper sending of thrust that you can then push into some sort of a 2 atmospheric housing or something like that, that gives you your measurable degree of actual thrust, So that's kind of what it was for. It was meant to make a very highly efficient, incredibly viable, cheap, easy, mass-producible prop that could get you into the upper Mach ranges for less energy than it takes for a typical jet engine will. And a wind mill that makes its own degree of continuational energy. It's like a flywheel when it's just a windmill. It will eventually die down. The vacuum goes away. It will be filled back up again. It doesn't stay. But, it's kind of like that, and another gust and so on comes around, and you'll be able to continue the effect. And so as a result, you continue having this very efficient, very fast flow rate windmill design. But again, it will eventually not have wind. And so I was like, well, what about the jet stream? The jet stream pretty much always has wind. We could just stick them up there. This makes total sense. Why don't we just do that? And again, it's talking to 1800 people, and they were like, there's no jet stream. There's no even upper atmosphere. There's no outside. I was like, I had to debate them so long for that. Pissed me off. I was like, I'm here in 15 or something talking to them. 2014, anyways. Doesn't really matter. Point is, it was like, this is annoying. Why don't you know? Oh, right, you're in the 1800s. It's not your fault. You'll get there. It's there. Trust me. You'll find out. You'll find it. And then lo and behold, I'm here, and they found it. Wow, there is a jet stream. Crazy. So, you know. But anyways, there you go. That's the whole wind blade design, all that. And the coffee is not bad. Alrighty, bye.